Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to electricity in the chapters of DC voltage and resistors. This exercise was a previous one in the Brevet exams in 2010, third session, second exercise. The title of this exercise is Measurement of an Electric Resistance. We connect in series a generator G that maintains across its terminals a constant voltage U is equal to 12 volts, a milliammeter A of negligible resistance, and a rheostat D of adjustable resistance. Then a current I flows through the circuit. Number 1. Draw a diagram of the electric circuit thus formed. This electric circuit consists of three electric components: the generator, the ammeter, and the rheostat. So this is the generator G. Okay, here we have the ammeter A, and here we have the rheostat. So the rheostat is a resistor of adjustable resistance. Now this is the symbol of the resistance, which is denoted by D. Because it is of adjustable resistance, then the symbol is given by this. And the electric current I is flowing the circuit because it is a closed circuit. Then this is it for part 1. Now in number 2 they are telling me what's the voltage UA across the terminals of the milliammeter. Notice that here the milliammeter of negligible resistance, then the voltage across the milliammeter is 0 because it is of negligible resistance. Then UA is equal to 0. Now in number 3 they are telling me show that the voltage UD across the terminals of the rheostat is equal to 12 volts. Notice that here the generator maintains across its terminals a constant voltage U is equal to 12 volts. Then here U is equal to 12 volts. Then we know that the voltage across the battery is 12 volt and the voltage across the ammeter is 0. Then we can calculate the voltage UD across the rheostat using the law of addition of voltages. Then apply law of addition How do you apply this law? Always on the left we'll write the voltage of the battery, which is given by, in this case, U, and on the right we'll write on the other side we'll write the voltages across different electric components, and they are given by UA plus UD, making sure that UD will appear in the equation. We are interested in calculating the value of UD. The value of U is given by 12, the value of UA is given by 0, and we keep UD as a variable. So this is a linear equation and one unknown. Then the value of UD is given by 12 volts. So we have in this case that UD is equal to 12 volts. Now in part 4 they are telling me, part A, show that the current I is given by the expression I is equal to 12 R's, to 12 divided by R. Then we need to prove that the current I traversing this electric circuit can be written as 12 divided by R. So this is a relation between the electric current and the resistance, and probably that this 12 here is for the voltage. So it's the relation between the voltage, the resistance, and the current, and this is given by Ohm's law. Then let's apply Ohm's law to the rheostat D. Apply Ohm's law to D. And Ohm's law is given by U is equal to R multiplied by I. Constructing the triangle of this formula, you at the top, R and I at the bottom. We are interested in calculating the value of I. Then I is equal to U divided by R. The voltage across the electric component is given by UD. Now the value of UD is equal to 12. Since we want R to appear in the equation as a variable, so we'll keep it as a variable. So I is equal to 12 divided by R. Now in part B, they are telling me find the value of R such that the milliamp meter indicates as 6 milliamps. So here let me write that I is equal to 12 divided by R. Then we need to find the value of R, knowing that the milliamp meter indicates 6 milliamps. Here the milliamp meter is reading the value of the electric current I. Then the value of I is given by 6 milliamps. So I is equal to 6 milliamps. We know that milliamps is not the SI unit of electric current. In order to convert from milliamps to amps, we divide by 1000. Then dividing 6 by 1000 will give us 0.006 amperes. Now knowing that I is equal to 12 divided by R from part A of part 4, and now we know that the value of I is given by 0.06 amperes. We are interested in calculating the value of R because they are telling me in part B find the value of R. So 0.06, which is the value of I, is equal to 12 divided by R. Then this is an equation in one unknown. The unknown is given by R. So how do we solve this equation? We put R on one side and all the other numbers on the other side. So here we divide by 1 and we crisscross. Then R is equal to 12 divided by 0.006. Now plugging this fraction on the calculator will give us 200 ohms. Then the value of R is equal to 200 ohms in this case. Sorry, 2000 ohms. Okay, so this is it for part B. Now in part 5 they are telling me vary R. Then here the rheostat, because it is of adjustable resistance, then we are varying the value of R. The adjacent curve shows the variation of I as function of R. Now in part A they are telling me find graphically the value indicated by A for R is equal to 4000 ohms. We are in 5, part A. Okay, they are telling me find graphically the value indicated by A for R is equal to 4000 ohms. In other words, we need to calculate the value of I because the ammeter indicates electric current, and because we are using the graph or the curve, let's say graphically. So they usually give a half a mark for this statement. For R is equal to 4000 ohms, we have, so if this is 2000 ohms, this is 4000 ohms, and it corresponds to this point on the curve. Now this point has an electric current of, if this is 2, then this is 4, this is 6, this is 8. So the value of this electric current is given by 3 milliamps. Then we have I is equal to 3 milliamps. Then the value of I is given by 3 milliamps. Now in part B, they are telling me find again graphically the value of R for I is equal to 6 milliamps. They are telling me again because we already in part 4B we have determined the value of R for I is equal to 6 milliamps, and the obtained result was given by 2000 ohms. So here we expect that using this curve we will obtain the same result, which is given by R is equal to 2000 ohms, or uh, if the result is not in agreement, so probably we have done something wrong. And now in part B, because we are using the curve, let's say graphically, I repeat that they usually give a half a mark for this statement. Now for I is equal to 6 milliamps, and let me clarify here that the advantage of this curve is the following, is that if we know the value of I, we can determine the value of R, and if we know the value of R, we can determine the value of I by referring to this curve, as we are doing here in parts A and B of part 5. Now for I is equal to 6 milliamps, we have, now I is equal to 6 milliamps, this is I, so this is 2, 4, 6. Now 6 milliamps corresponds to this point on the curve, which has a resistance of R is equal to 2000 ohms. Then we have R is equal to 2000 ohms, which is the same result of part 4b. Now in part 6, they are telling me the circuit thus formed plays the role of an electric instrument that allows to measure the resistance of a resistor. Give the name of that instrument, and we know that the name of this instrument is given by the ohm meter. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.